Welcome to the lesson on the control phase of the Six Sigma DMAIC model. Upon completion of this lesson, learners will be able to explain the control phase and recognize the tools associated with the control phase of the DMAIC model. The control phase of the DMAIC process serves a critical function after improvements have been implemented. Its primary purpose is to establish robust checks and balances that verify and maintain the enhanced quality of the process. This stage ensures that the implemented solutions deliver the intended improvements and continue to do so over time. Even after the optimal process improvement plan has been implemented, the project still must go through the final control step. Maintaining the improvement is a long-term job. The control phase is a way to sustain the improved system by documenting the key aspects of the project, noting the best practices learned by the team, and making a plan to sustain the system. Let us take a look at one of the important terms in the control phase: statistical process control. This is a quality control method that employs statistical techniques such as control charts to monitor and control processes. It primarily uses control charts to track process performance over time, enabling the identification of when a process falls out of statistical control. SPC is particularly valuable for its ability to detect process shifts or trends early, allowing for timely interventions. The method establishes upper and lower control limits based on historical data, providing a clear framework for assessing process stability and consistency. Earlier, we discussed how control charts are used to analyze the causes of process variations in the analyze phase. Control charts can also be used in the control phase as a process monitoring tool. A control chart is a process monitoring tool in statistical quality control. This graphical instrument displays process data over time, allowing for visual analysis of trends and patterns. It plots the process mean and variability against predetermined control limits, providing a clear representation of process performance. The chart's primary function is to help differentiate between common cause variations that are inherent to the process and special cause variations that indicate potential issues. By doing so, it enables managers to monitor process stability effectively and quickly identify out-of-control conditions, facilitating timely interventions and continuous improvement. A process can either be in control or out of control, based on the control limits. A process with only common cause variation, or variation within the upper and lower control limits, also known as UCL and LCL, is said to be in statistical control. Conversely, a process whose variation exceeds the control limits is said to be out of control. Let us discuss what an X-bar chart is with an example discussed earlier in this module. Here, the mean of each sample is plotted on the chart. A control chart with the mean as the metric of interest is called an X-bar chart. In this case, 20 samples were taken. The measured mean can be any characteristic of interest, but for this example, the quality characteristic is the gap between the fender and the front bumper. The center line represents the mean value of 3.5 millimeter. The upper control limit is 3.7 millimeter, and the lower control limit is 3.3 millimeter. The upper and lower control limits represent 3 sigmas above and 3 sigmas below the center line. Each of the 20 samples is taken from a specific time interval. For example, sample 1 could represent data from 6 a.m. to 7 a.m., sample 2 from 7 a.m. to 8 a.m., and so on. Now let us discuss about the range chart, or the R chart. A control chart with the range as the metric of interest is called a range chart or an R chart. In this example, the range of each sample is plotted. For example, 5 observations were taken within each of the 20 samples. The difference between the highest value and lowest value within the sample is recorded as range. Because both the X-bar chart and R chart are within their corresponding control limits, the process is said to be in control. Control charts are used to identify out-of-control processes quickly before it becomes a major issue. In summary, the control phase of the DMAIC model utilizes control charts to ensure that the process is statistically within upper and lower control limits. Tools used in the control phase include X-bar and R charts. In addition to process control, the control phase involves the team documenting their improvement process and developing a sustainability strategy for the newly implemented system. Thank you.